For 40 years, we were wrong. Dead wrong. For 4 decades, the official textbook scientific consensus on the planet Uranus was that it was, to put it bluntly, boring. For 40 years, we were wrong. Dead wrong. For 4 decades, the official textbook scientific consensus on the planet Uranus was that it was, to put it bluntly, boring. A dud. A placid, frozen, inactive ball of ice and gas just sitting out there. Voyager 2 flew by in 1986, took a look and basically said, yep, it's blue. Nothing else to see here, folks. It detected no excess heat out of Uranus. None. The planet was a perfect thermal mirror, only radiating back the energy it got from the sun. It was the only gas giant to do this. A total anomaly, a freak of cosmic bookkeeping that made it the quiet, boring sibling in a family of raging lunatics like Jupiter and Neptune. And for 40 years, we just accepted that. Until now. Until a 2025 study comes along, blows the dust off the old data on Uranus, and applies some ridiculously clever new math and finds it. The heat out of Uranus. It was there all along. Uranus is hot. It's alive. It radiates 12% more energy than it gets from the sun. And this is the moment right there that fractures the entire story of Uranus into 2 pieces. Because this is a story of absolute 10 out of 10. Pop the champagne, scientific brilliance. A masterclass in how we correct our own mistake. But it is also a story of some of the most frustrating speculative, let's just connect the dots with invisible ink, interpretive fumbles that make me want to tear my hair out. So that's our mission today. We're diving headfirst into the beautiful, infuriating paradox of Uranus. How can a planet we just discovered is actually interesting also be the subject of such wild, unsupported speculation? How can the science be so good and some of the conclusions drawn from it be so bad? This is a tension deconstruction of a planet, Uranus. So let's get into it. Okay, so first, let's give credit where it's monumentally due. Let's talk about the peak of brilliance, the absolute triumph. Dr. Wong Shinye and the teams at the University of Houston and NASA Langley. Get these names because what they did is nothing short of scientific necromancy. They resurrected a dead planet out of Uranus. You have to understand the scale of the problem they were facing. So why did Voyager 2 get it so wrong? One word. Seasons. But seasons on Uranus are not like our quaint little 3-month affairs here on Earth. Uranus is a freak. It's an axial tilt in 19.8 degrees. That far. It's almost, way off. It's not spinning like a top. It's rolling like a barrel through the solar system. This means for 20 straight years of Earth years, one pole is blasted by non-stop continuous sunlight, while the other pole is plunged into 2 decades of absolute freezing darkness. Then for the next 20 years, they slowly swap. When Voyager 2 did this flyby in 1986, it was peak summer in the southern hemisphere of Uranus. The South Pole was getting absolutely cooked. The South Pole being the South Pole of Uranus. The planet's atmosphere, especially within this thick methane cloud, has an immense thermal inertia. It's like a giant cast iron skillet on Uranus. You can have the burner on high for ages because the whole thing gets hot. And once it stays hot for long after you turn the stove off. So, the scientists in 2025 realized that the heat Voyager was seeing was almost all old heat. Stored up solar energy that was just now making its way back out Uranus. The planet's real internal heat, its primordial heat from formation, was completely masked by this overwhelming seasonal glare out of Uranus. So what did they do? Well, they built a better model. They built iterative radiative transfer models. That's a mouthful, but what it means is they essentially taught a computer to understand Uranus. Well, the seasons of Uranus. They factored in the 84-year orbit. They factored in the 98-degree tilt. They factored in the opacity of the methane clouds coming out of Uranus. And most importantly, they factored in the phase lag of Uranus. And this is the genius part. They calculated it. It takes about 63 Earth years. That's 3/4 of the Uranus orbit for the peak heat from the sun to be absorbed, go deep, and then radiate back out. So, Voyager flew by and measured the temperature at the worst possible moment out of Uranus, when the planet's own heat signature was being drowned out by the thermal noise of its own summer. The Wong and Langley team created a seasonal correction algorithm. It's like being an audio engineer for a planet. You have this messy audio track with a loud hum in the background. Their algorithm is the ultimate noise cancelling software. They filtered out the seasonal hum, and for the first time in the silence, they heard it. The planet's own heartbeat. A tiny but persistent internal heat flux of 0.45 watts per square meter out of Uranus. They did the math. They did the monster math, and it worked. After 40 years of thinking Uranus was a cold, dead world, we finally had proof that Uranus was alive. It fills the pattern. Jupiter, Saturn, Neptune, they all have internal heat. Now, Uranus is back in the family. It might be the weird cousin that sits in the corner, but it belongs. Hey, this is a moment of pure, unadulterated scientific joy. It's a statement to patience, to better technology, and to the sheer refusal to let a mystery lie. A perfect, beautiful synthesis of old data and new thinking, which only makes the next part of Uranus more baffling. Okay, so we now know that Uranus has internal heat. It's a fact now. It's a low heat flux, way lower than its twin Neptune, but it's real. And this new solid fact immediately becomes the foundation for some of the most speculative, wibbly-wobbly house of cards logic I've ever seen attached to a major discovery on Uranus. And it all centers on Uranus's tiny battered moon, Miranda. Now, some of these analyses are refreshingly honest about flagging this as speculative. And they try to suggest that Uranus's internal heat dynamics could be influencing a putative subsurface ocean on Miranda. So let's stop right there. Let's just put a full stop on that. This is the pit of despair, the rant spark, because this idea is so frustratingly untethered from reality that it borders on science fiction. It's like finding out your quiet neighbor plays the clarinet and then leaping to the conclusion that his clarinet playing is responsible for the stock market fluctuations in Japan. There's no conceivable mechanism for this to be true, but let's break down why this is an anatomical misstep of epic proportion. First, scale and distance. Miranda orbits Uranus at a distance of 130,000 kilometers. Uranus's newfound internal heat flux is 0.5 watt per meter square. It's a whisper of heat, barely escaping the planet's own deep insulating atmosphere. The idea that this minuscule, internally trapped heat could conduct or radiate across 130,000 kilometers of vacuum with enough energy to influence anything in Miranda, let alone sustain a subsurface ocean, is physically absurd. It violates pretty much everything we know about thermodynamics, to be honest. But the argument gets slightly more nuanced by suggesting maybe it's not the heat itself, but the asymmetry of the heat. The 2025 study found that hemispheric asymmetry in the heat flux alone. One hemisphere is emitting slightly more heat than the other, probably due to the lingering effects of those insane seasons on Uranus. The suggestion is that this asymmetry could somehow influence Miranda. But how? Just how? How do they think the planet is a giant heat lamp pointed at one side of the moon? The sheer gravitational force of Uranus is what dominates Miranda's existence. And even that is only enough for tidal locking, and not significant tidal heating like we see in Jupiter and Io. The idea that a thermal imbalance on the planet could have a tangible effect here, it's just, it feels like that there's nothing there. It's not a theory, it's a word salad, right? So this is a classic case of what I call speculative Jenga. You have one solid proven block at the bottom, that is, your anus has internal heat. Then you start stacking unproven wobbly bricks on top of it. So block 2 is Miranda might have a subsurface ocean. This is already speculative. Its bizarre patchwork surface suggests some past geologic activity maybe, or even cryovolcanism. But an ocean? It's a huge leap. It's a hypothesis at best. And block 3 on top of that, the ocean, if it exists, needs a heat source. Well, that's true. There are much more plausible candidates, like radiogenic heating. The decay of radioactive elements in Miranda's rocky core is probably more likely. It's a small moon, so it wouldn't be much heat, but it's a real known physical process. Another is maybe past tidal heating from orbital resonances with other Uranian moons like Ariel or Umbriel. This is also a well-understood mechanism we see elsewhere in the solar system. And block 4, the wobbliest block of all, is let's ignore those plausible explanations and claim the heat source is the asymmetrical hit from the parent planet 130,000 kilometers away. Okay, and the whole tower becomes wibbly-wobbly and timey-wimey. What's so infuriating about this is that it takes the genuinely brilliant heart-won discovery about your anus's heat and cheapens it by attaching it to this weird speculation. But hey, it's science. Speculation is fine. Let's come up with the evidence. It's a betrayal of scientific rigor. Sure, fine. People would probably say that. It gives us the discovery. Yeah, okay. But then it's like a Michelin star chef preparing a perfect dish, and then someone at the table drowns it in A1 ketchup and says, "Look what I made." Whenever I see claims like this, I always ask, what is the counter argument? And the defense is always something flimsy, like, well, you can't prove it's not happening, but that's not how science works. The burden of proof is on the one making the extraordinary claim. And the claim that your anus's subtle heat burps are cooking Miranda's interior is about, well, it's kind of extraordinary. Maybe. It feels like someone says, my source is that I made it the fuck up. And that's what it feels like. Press X for doubt. Okay, rant over. Let's put the Miranda mess in the bin while it belongs and get back to the real fascinating implications of your anus's internal heat. Because the story doesn't end with just finding it. The real question is, why is it so low? And this is where the nuance comes back in. Uranus and Neptune are ice giant twins. They are roughly about the same size, same mass, same composition, yet Neptune radiates 2.6 times the energy it receives from the sun. It's a furnace. Uranus, we now know, only manages a paltry 1.125 times. They are twins, but one is running a marathon while the other can barely get off the couch. So why? Well, the current leading hypothesis is just as cool as the heat discovery itself. It's all about suppressed convection. Inside your anus is a giant sloshy mantle made of water, methane, and ammonia ices under immense pressure. Normally in a gas giant, this region would be churning like your mom. Hot stuff rises, cool stuff sinks. This is convection, and it's the main elevator that brings heat from the deep interior up to the surface to be radiated away. But on your anus, something seems to be jamming the elevator. The theory, or at least the current working theory, is that the mantle isn't a uniform slush. It's stratified. It's layered like a planetary parfait. There might be a gradient where the deeper layers are richer in heavier molecules. This stratification would act as a massive break on convention. Instead of a rolling boil, you get a gentle, sluggish simmer. And what's the secret ingredient that could cause all of this? Ammonia. Ammonia acts as a cosmic antifreeze. In that high-pressure mantle, it can lower the freezing point of water, creating a dense, viscous, semi-liquid slurry that is just bad at moving. It's like trying to boil honey. You can heat the bottom of the pan, but the heat isn't going to get to the top very efficiently. So, your anus isn't cold because it lacks heat. It's cold because it's pathologically bad at letting its heat out in a fart. It's an insulated thermos planet, holding on to its primordial warmth from 4.5 billion years ago with a death grip. It's basically butt clenching. And we even have a clue what to that this might be true. A gravitational anomaly. NASA's measurements have found a spot at 45 degrees north latitude on Uranus where the gravity is slightly different than expected. This suggests a density variation deep below, exactly what you expect if there was a sluggish, localized plume of that weird ammonia water slurry slowly pushing its way upward. It might even be the source of the cryovolcanic activity. Instead of fiery volcanoes, it was icy volcanoes erupting slushy volatile, coming out to the surface to fart out of Uranus. It's a geological process happening in super slow motion. And this is so much cooler than the Miranda story. This is a real tangible mystery grounded in data. We have a planet, Uranus, that has fundamentally different internal dynamics than its own twin. It's a story of composition, of chemistry, of high-pressure physics. It opens up a whole new avenue of understanding how ice giants evolved. Are they all born out of the same, and some just say stall out like Uranus? Or are they two fundamentally different models from the start? But this too leads to a different kind of frustration. The limits of our knowledge. Our only up-close look at Uranus' atmosphere was the Voyager 2 radio occultation experiment. It pierced the atmosphere down to a pressure of about 2.3 bars. That's it. That's like trying to understand Earth geology by analyzing the paint on the outside of a skyscraper. All these brilliant models about deep water clouds, ammonia slush, and stratified mantles are happening hundreds, even thousands of bars below where they've been. The hypothesized water clouds, which could be a critical part of this convective inhibition story, are thought to be from between 500 and 3,000 bars. We haven't even gotten close. So, we have this incredible paradigm shift, a resolution to a 40-year-old paradox that immediately slams us face first into a new brick wall of unanswered questions. A new data confirms Uranus has minimal internal heat engine. This explains why its atmosphere is so much calmer than Neptune. Neptune's powerful internal heat drives massive storms, like the Great Dark Spot. It's a dynamic, violent place. Uranus, with its feeble heat engine, can only muster up transient shallow storms in its upper atmosphere, mostly driven by the condensation of methane. Its deep interior is decoupled from its upper atmosphere. There's a barrier, a boundary that the heat can't efficiently cross. We can see the effects of this. The extreme season should, by all rights, create massive temperature gradients and wild planet-spanning weather. But they don't. The planet's high thermal inertia and that 63-year phase lag acts as a planetary shock absorber. So, the polar regions heat up and cool down so slowly that the atmosphere remains relatively stable and almost placid. It's a system that is actively working against its own dramatic setup. And even the heat that does escape is weird. The hemispheric asymmetry with the southern hemisphere currently emitting more energy is likely a leftover thermal imbalance from its latest solstice, when the South Pole spent 42 years in continuous sunlight. It's got a deep thermal suntan and it's still radiating away out Uranus decades later. We are watching the slow exhale or fart of a decades-long summer. It's poetic. So here we are, Standing on a mountain of new understanding, staring out at a sea of new mysteries, the work of Wang and Langley was like finding the Rosetta Stone for Uranus. But now we have to actually go translate the damn thing. We need to get back in there, get back to Uranus. We need a dedicated Uranus orbiter and an atmospheric probe. We need to drop a probe deep into Uranus and see if those water clouds are really there. We need to measure the composition directly. We need to map the gravity field with 1,100 times more precision to see if there are more anomalies, to trace the shape of that sluggish convection. We need to watch a full season unfold and not just a single snapshot from a 1986 flyby. Because Uranus is no longer a boring planet. It's the hard mode planet. It's the subtle planet. Its secrets are not written in giant raging storms, but in faint thermal whispers, in minute gravitational deviations, and in the complex chemistry of a high-pressure slushy mantle. It's a planet that makes you work for it, and the reward is a fundamentally deeper understanding of how these ice giants take. So, in the end, we're left with this beautiful, messy, contradictory picture of Uranus. The story of Uranus in the 21st century is a story of incredible scientific redemption. A 40-year-old error on Uranus corrected with brilliance and ingenuity. We took the ghosts of Voyager's data on Uranus and through sheer analytical power gave the planet Uranus back its fire. It's a moment that should reaffirm all of our faith in the scientific process. But it's also a cautionary tale. A tale of how easily a solid fact about Uranus can be used as a springboard into the abyss of speculation. The temptation to connect the dots, to build a grand unified theory of Uranus based on a whole planetary system is powerful. But when these connections are not supported by evidence or a plausible physical mechanism of Uranus, they harm the conversation, honestly. The ridiculous notion of Uranus heats affecting Miranda is a perfect example. It's a distraction from the real, far more interesting and far more difficult questions that are staring us right in the face. So, what is Uranus now? It's not that simple, cold, dead world we thought it was. It's a planet with a choked, suppressed, but persistent inner fire. It's a world whose personality is defined not by its energy, but by its profound inability to express that energy. A world of extreme seasons that are paradoxically dampened into near irrelevance by its own atmospheric inertia. It's an ice giant that is fundamentally and perhaps permanently different from its own twin. And that leaves us with the ultimate question, the one that a future mission to Uranus will have to answer. Was Uranus just unlucky? Did it form in a way that left Uranus' interior stratified and sluggish? Or did something happen to Uranus? Some ancient giant impact up Uranus that literally knocked it on its side and stirred up its interior in a way that scrambled its evolution forever. Is Uranus a sleeping giant? Is Uranus a failed furnace? Or is Uranus something else entirely? A planet that is playing by its own bizarre, infuriating, and beautiful set of rules. That's the mystery. And it's 1,000 times more compelling than any fantasy about seeding its moons from a distance. So let me know in the comments if you were on a designing team that designing the next mission to Uranus, what one instrument would you insist to bring up Uranus? And what question would you be trying to answer up Uranus? Let's talk about it. I'll see you in the next deconstruction.